Welcome everybody. Today I would like to talk a little bit about the Taylor rule and the difference between a monetary policy rule and a discretionary monetary policy. I'll also talk about automatic stabilizers and the time inconsistency problem in monetary policy. So let's start with the introduction. So the Taylor rule was regarded to be a simple rule, like a rule of thumb, intended to describe the interest rate decision of the Fed. And it should be like a valuable description. It should be a valuable descriptive device. However, this view changed over time. Like recently, Ben Bernanke wrote that nowadays John Taylor began to argue that his rule should also prescribe as well as describe the interest rate decisions and should be a benchmark for monetary policy. So in the beginning, Taylor just said that it should describe the interest rate setting, and now he's more has a more normative view on this kind of issue. So, what is the difference between a monetary policy rule and a discretionary monetary policy? I would like to highlight this by giving an example for a discretionary monetary policy. I would like to discuss a shock in the ISLM model. We have here the IS equation, and the assignment question is that you should analyze a shock in money demand. Money demand increases, and then it might be the case that the central bank opts, make an active decision for an anti-cyclical monetary policy, and one anti-cyclical monetary policy tool could be to increase money supply. Let's refresh our knowledge with respect to the ISLM model. So, what about the IS curve? The IS curve shifts to the right in case that one variable changes, which has a positive impact on the demand for goods. So in case that the autonomous component of consumption increases, in case that taxes decrease, in case that investment increases, or in case that government increases government spending, the IS curve shifts to the right. So when it comes to the LM relationship, then it will be the case that the LM curve shifts to the right in case that money supply increases, in case that the prices decrease, or in case that the autonomous component of money demand decreases. So the assignment question is to analyze this shock here. The autonomous component of money demand increases, so a positive money demand shock. And hence we know from this slide that the LM curve has to shift to the left. So let's analyze this kind of stuff in the interest rate income diagram. Once more, we have two equations, like the IS equation and the LM equation, like the goods market equilibrium condition and the money market equilibrium condition. We display these two equations in a diagram as the IS curve and the LM curve. And since we have two equations, we can solve for two unknown variables. We can determine two endogenous variables simultaneously, which is the interest rate level and the income level. So right now, the equilibrium is in this point here. So the equilibrium interest rate is at 10, and the equilibrium income level is at the level of 2000. So now we said that money demand increases. So money demand increases, the variable D0 increases. This shifts the LM curve to the left. There is a new LM curve, LM1, and we get into like a new equilibrium like point B. This is the initial equilibrium point A. So overall, it is the case that like the interest rate increases in this graph from the level of 10 to the level of 15%. And due to this increase in the interest rate, it is the case that income drops, so the economy ends up in a recession. So what can the central bank do in order to counter this effect? The central bank could like implement an expansionary monetary policy and shift like the LM curve back to the right. So the central bank has to make a decision now. The central bank has to opt for an increase in money supply, and then the LM curve will shift like into its old position, and we'll get like an equilibrium here in point C, which is like equal to the old equilibrium in A. But it is the case that point B would be an equilibrium. So in case that the central bank does not react, in case that the central bank does not make a decision, then we would stay in point B like forever. But the central bank can make this decision and the economy will get out of recession. But what is important to emphasize here is that the central bank like has to make a decision, which I mentioned here. So the central bank has to opt for an anti-cyclical monetary policy. It's not an automatism, but the central banker has to gather, they have to discuss this issue, and then they come up with the right decision. In the next step, I would like to talk a little bit about automatic stabilizers, because in the original Taylor paper, which was published in 1993, it is a case that he also talked about the benefit of automatic stabilizers. So let's use a very simple macroeconomic model. So I'm opting here for a pure goods market model, chapter 3 Blanchard, and a negative investment shock occurs. So like the autonomous component of investment decreases by 1 unit. And the assignment question is that you should compute an income multiplier. So this can be done in the following way. We have here like the goods market equilibrium condition. Left-hand side, goods supply. Right-hand side, goods demand. We have like consumption here. We have investment here and government spending. Now we take a total differential and write a D in front of each variable. We have to be careful because like C1 is a parameter, like the autonomous component of consumption is a parameter, and we do not write a D in front of a parameter because one implicit assumption is that the parameters are constant, parameters do not change, and therefore we don't write a D in front of the parameter C1. In the next step, we have to think about what changes. It is the case that the autonomous component of investment changes by 1 unit. The autonomous component of consumption is constant, and therefore the change in this variable is equal to 0, and this term drops out. Also, government spending is constant, and therefore the change in government spending is equal to 0. So we end up at equation 4. We are putting C1 dy on the other hand side of the equation, pops up with the negative sign here. We write dy out of brackets, arrive at this term, and when we divide this expression by 1 minus C1, we put 1 minus C1 on the other hand side of the equation, should pop up in the denominator of a fraction. We put 1 minus C1 on the other hand side of the equation, and we also divide by dB0 so that we have here our multiplier. dy dB0 is equal to 1 over 1 minus C1. In case that the marginal propensity to consume is equal to 0.8, then the value of the income multiplier is equal to like a +5. This has to be interpreted in the following way. In case that the autonomous component of investment increases by 1 unit, then GDP will be up by 5 units. But here in this example, it is the case that the autonomous component of investment decreases by 1 unit, so that GDP is down by 5 units. So like we have a negative goods demand shock, and in the end, GDP will decrease by 5 units. This is a scenario like without an automatic stabilizer in place, so completely in line with the chapter 3 Blanchard. Now let's plug in an automatic stabilizer. So like we assume that government expenditure depends on GDP. In case that GDP is high, or in case that GDP increases, government expenditure will be lower because of the fact that, for example, welfare payments are lower. Unemployment insurance payments are lower in a boom. What happens if there is a recession? So in case that Y is low or Y decreases, then it will be the case that government expenditures increase, because like there is a negative sign in front of G1. So now we have to define the right hand side here. Like G0 is an autonomous component of government spending, and then government spending also depends on GDP in a negative way. And G1 is also like a parameter, and we assume that G1 is constant. So then this is our goods market equilibrium condition in case that an automatic stabilizer is included. So we have one additional term here. We take the total differential, and once more we are assuming that like this variable is constant, and also like that variable is constant, so that the changes are equal to 0. We put C1 dy on the left hand side, pops up with a negative sign, and we also put up minus G1 dy on the other hand side of the equation, and now pops up here with a positive sign. We can write dy out of brackets, so we have 1 dy here, a minus C1 dy there, and a positive G1 dy there. When we write dy out of brackets, we have this term here in brackets, and then we are dividing by the term in brackets. We also put dB0 on the other hand side of the equation, and we end up with this multiplier here. So we once more assume that C1 is equal to 0.8, the same numerical value as in the last example. And then we are assuming that G1 is equal to 0.05. So how large is now like the multiplier? The multiplier like takes a value of 4. And hence it is a case that when investment decreases by 1 unit, GDP only decreases by 4 units instead of 5. So there is a benefit of an automatic stabilizer because of the fact that when this automatic stabilizer is in place, a negative goods demand shock has a smaller impact on GDP compared to the situation without an automatic stabilizer. So there is a clear benefit of an automatic stabilizer, and the benefit is that like the negative goods demand shock has a smaller impact on GDP because like the government automatically starts to increase welfare payments, or like the people have like a kind of unemployment insurance, and therefore like the effect on GDP is lower. So I have talked about this topic here, like automatic stabilizers. I hope that you are doing well. Maybe it's time for a short break here because I want to start like a completely new topic. So in case that you want to make a short break, then make the break here. So the next topic, time inconsistency, stems from the Bofinger textbook. So I'm in chapter 3, subchapter 6.6, time inconsistency, arguments, and the Barrow-Gordon model. Like this is the chapter of the Bofinger textbook. I'll not go into detail, but I'll only try to give you an intuition like why it could make sense to have a monetary policy rule in place instead of discretion. So the big question is like, why is a rule beneficial? The conditions for a time inconsistency problem are as follows. Like one of the two players is completely free to choose the strategy, while the other player has to be committed to a strategy at one point in time. So we are looking at a sequential game. It's a one-shot game, no repetition, and therefore no reputational arguments play a role. So one example, at the beginning of the semester in time period T0, the professor announces that an exam will take place at the end of the semester. Like during the semester, the students study hard. So in the time period T1, the students study. And then in the end, the professor is canceling the exam in a time period T2. Big question is, what if the students anticipate the behavior of the professor? So let's have a look at the different outcomes and try to order the different outcomes which are possible. Like the best outcome is students study hard and the exam is cancelled. Why is that the best outcome? It's the best outcome because the students study hard, so they learn something, but like the exam is cancelled and the professor doesn't have to grade the exams. So the professor can focus on research, or the professor can prepare for the next lecture, but so that the professor can save some time. The second best outcome is the students study hard, so the students learn something, and the exam takes place at the end of the semester. So there is one disadvantage compared to situation 1, because the professor has to grade the exam. Number 3 outcome, third best outcome is students do not study and the exam is cancelled. And the worst outcome is students do not study, but the exam takes place. This is a worst outcome because for the professor, it is a mess. Like the students have not studied. It's very hard to grade exams where a lot of mistakes occur. So that's really pain in case that the students have not studied, but the professor has to grade this exam. Therefore, it would be even better, like students have not studied and the exam is cancelled, because then the professor can save the time he would have to take for grading the exam. So let's analyze this decision tree. In time period T1, the student has to make a decision to study or to be lazy. So the student has to commit or not to commit to the study. And then the professor can make the decision in time period T2 whether to give an exam or to have no exam. Let's check what happens if the student is studying. What is the best response then of the professor? So when the students are studying, the best response is to cancel the exam, to have no exam in place. What if the students are lazy? What is the best response like for the professor? When the students are lazy, it doesn't make sense to grade an exam like which is completely wrong. So therefore, also here, the professor will cancel the exam. So it is a case that the students can anticipate that the professor has no incentive to give the exam in the end. And therefore, the students opt for like not to study. And the final result is that the students are lazy and like no exam takes place. So let's have a look. So like the outcome of the game in case that the university has no rule in place is students do not study and the exam is cancelled. So how can we end up in one of the better outcomes? So like one idea is that like the university has a rule that there has to be like an exam in the end of the semester. So that there is a university-wide rule, and the university-wide rule says this is not an option at all for the professor. So there has to be an exam in the end of the semester. And since the students know that there has to be an exam, it is the case that they start to study and the exam takes place because like there is this university-wide rule in place. So like with the rule in place, it is the case that at least the university system can reach like the second best outcome, like the students study, and in the end, like the exam takes place. So there is an improvement, like without the university-wide rule in place, it is a case that the system ends up in the third best scenario, and with the rule in place, the system ends up in the second best outcome. So I think that this is mentioned on this slide. So with the university-wide rule, the announcement of the professor to schedule an exam in the end of the semester becomes credible for the students. The students know for sure that an exam takes place and the students study. And in the exam, the rule secures that the exam takes place. What does this have to do with monetary policy? Where's a link to monetary policy? So there's also a time inconsistency setting in macroeconomics because the central bank might announce a low inflation rate in period 0. And then the labor unions and the employer organizations, they fix the wage contracts for the next 2 years, and they fix the nominal wage W in T1. And then the central bank has an interest to surprise the market with a higher inflation rate to reduce the real wage. So when the nominal wages are fixed and prices are up, the real wage decreases, and a lower real wage would increase employment and decrease unemployment. But now, of course, the big question is, what if labor unions anticipate the behavior of the central bank? Then the whole system will end up in a scenario where a relatively low utility is realized, and it makes sense to have a rule in place that the central bank should have an eye on inflation and should keep the inflation rate relatively low. Therefore, like the most central banks of the world, they have an inflation target. Like this is the end of the introductory lecture. Thank you so much and have a nice day. Bye-bye.